Good afternoon. I saw you guys have been going through a long day today for all the very serious sessions. So what you're going to do now is something very light, very simple. Just go through with me. It's going to be very introductory. It's going to just show you how you can actually do this on the web. Probably most of you wouldn't have known that you can do that as well. So before I begin, just a quick question, sir. How many of you are actually here for the VR aspect of the sessions, of the topic, the VR aspect, the VR on the WebXR? Hands on? No? Anyone? Okay, not too many, but what, 5, 6? Okay, how many of you are actually for the NFT part of it? Oh, shit. I'm sorry. I mean, yeah. Okay, disclaimer, this is not, there's no financial advice. And this is not a topic about cryptocurrency or whatnot. We are really here to talk about the technicality and how we can actually interact with NFT as a very minor part of it. Okay? No price actions, no coins, no nothing. All right, cool. Let's get started. So first of all, hello, my name is Vin. I'm a Google developer expert on web technologies. I also currently run a project called Arteesan, where we actually build a web-based art marketplace for artists to sell and buy, for collectors to buy their artworks through the online platform. We also added a layer of NFT technologies to actually provide the provenance, we call it the certificates of authenticity by means of NFT, right? So that's pretty much what we do. Today, I wanted to share with you guys some little thing that I actually find it very interesting that we can actually do on the web itself, which is called building a virtual world on the web with WebXR technology, WebXR Device API, and with the NFT assets. You know, coupling all of these things together, right? There's actually one word that you probably know, heard of the word. Can anyone tell me the word? Sum up the whole topic for me under one word. Building a virtual with NFT. Anyone? Sorry, who's the first one? Oh. I am going to go with the one because I really hear them, okay? I would have something to give away. This is a Google Cardboard, not original Google Cardboard because Google discontinued it, but it's actually a cardboard for you. Thank you. So this is actually a simplest VR headset. You can get it for like under $5 in the States. Yes. Metaverse, as it stands, is basically a virtual world that has a persistent state that the users can move around with the assets they can bring into the world and bring out of the world, right? So it encompasses of 3 components. The first one is the virtual, the VR, and then the second one, in our case, we will be utilizing this web as a platform together. And last but not least, we will also be interacting with blockchain to retrieve the NFT assets of the wallet address of a user itself. So if you actually look into it, by and large, if we have a web plus a web technology, web technology plus VR technology is basically the immersive web itself, the immersive technology itself. And so a quick one. Who can actually share with me in your own words what actually is an immersive technology? Anyone? Immersive technology. No one want to try? You again, but you already got one. Sorry? Yeah, you can try. No one else, right? Can you help me with what is an immersive technology?
The line between the reality and my internet blurs? Using all your 5 senses?
You're going a bit further into the future. But at this point, in what we're trying to cover here in terms of immersive technologies are basically a set of technologies that interact with that helps to merge the real reality, our reality, and also the virtual world that we are actually can be simulated by the computers built by the developers itself. So the key takeaway here is that immersive technology is basically a collective set of technologies that can work with different realities and also work with different API, for example, unified gamepad input, controller input. Because in the virtual world, you may have a keyboard. Some of your users may have a keyboard. Some of your users will probably be using a VR set controller, and some of the users will probably be using a very low-end Google Cardboard controller. And then you have to have you have to have a single unified model to interact with all different kind of models. So this is what this entire technology covers. This VR AR thing is really not something very new. It dates back as early as 2015 and actually reached out to the market in about 2016. So it's really a something that's been around for a while. By and large, we have two distinctive ones. The first one will be 3 degrees of freedom, which basically you can rotate in 3 axes, Y, X, Z, where you can do pitching, yaw, and roll, right? So what 3 axes, X, Y, and Z, I think most of you will probably know. And then you have a more advanced headset, for example, like the Oculus Rift and also Hive and Index, the WAF Index and all that. These are all 6 degrees of freedoms headsets. It simply means to say, other than rotational movement, you can also have translational movement, where you can move towards left, right, front, back, and up, down itself. So combination of all these allows the users to actually move around and also look around in the virtual world. Okay. When we talk about realities, there are by and large 3 realities that we will be interacting with. The first one will be the one that we are more familiar with today is a virtual world, a virtual reality, where the users actually interact in a virtual world that is stimulated by the computer, entirely interacting with objects in the virtual world itself, right? That's virtual reality. And then, of course, we have augmented reality as part of this immersive tech. The augmented reality is basically the inverse of virtual reality. It means to say how we can render digital information in the real world, where we can see additional information and become helpful in our either productivity works or can be fun, can be for gaming as well. So you can think of it like, for example, the pilot, you have a headset with additional information displayed. Those are hard HUD or augmented reality headsets or augmented reality technologies. And then next, we have this thing called a mixed reality. Mixed reality is the difference from the augmented reality is basically how we can render the digital information and digital objects in the real world, not only just rendering on top of it, but also interacting with the real world. For example, it will be able to know about the depth of the object itself. And if you look at the slides, right? The objects we know is actually behind the chair, but it's in front of the tables. So it can actually render itself in the right positions with enough of depth and stuff. There's a lot of demos that you can see online. I probably don't have enough time to share with you guys, but the idea is as such, you can actually look around for more information. Yep. So all of this together encompasses the immersive technologies, where it covers from a reality and also the virtual world itself and everything in between, right? So you have a full VR, you have a VR, you have AR, you have MR and whatnot. So, but the thing is, these are all great and good. It's just that there is one problem, actually 3 problems. So the first one is, in most cases of these immersive technologies, you tend to have a gatekeeper. For example, if you are actually building for a Oculus game, Oculus headset, Oculus applications, you will have a store that is managed by a single party, a centralized party, to say, hey, your application, you know what, it doesn't meet our community guideline, I'm just not going to let you through. So somebody will have a say to say, you can publish your application or not, right? It's pretty much like our app in iOS, in Android, the same thing. So that's a gatekeeper. Number 2, almost all of your application in VR, you need some form of installation. If in the headset, you probably need to install a Oculus applications. If in your phone, you need to install an app. In your computer, you need to install a game. And they are usually come in large form and in large file size. So that's very, very difficult. And also, the platform will have a say to say, hey, you can how you can connect with other ecosystem, how you can connect with other party is entirely controlled by the platform itself. So this is the kind of limitation that we thought, hey, there should be some solution to it. And because of this limitation, we are basically limiting more people accessing the web, the VR world, the virtual world, and also the augmented reality technologies. So what we actually comes about doing, actually the W3C working group, they actually comes about to think how we can actually bring these entire technologies to the open web itself. That's where it emerged the whole immersive tech that we are talking about today. So what is the good part about the web? Why do we even want to bring this thing to the web, right? So as with any layer inheriting the web technology itself is by and large, by nature, by design, an open platform. Meaning to say, you can build your web-based application, web-based VR application or AR applications, and you can just put it on the internet itself without any permission from anyone. Nobody says you can or you cannot, right? You can just put it up there. Number two, it's instantaneous. For example, if you just visit a website and then you have the VR application, voila, it's running, and then the rest of the content is streamed behind, in the background itself. So these are also a very important attributes itself. And in the web itself, again, by nature, by design of the web today is actually interconnected. You can have your application to connect with any other platform, any other ecosystem as you see fits lah. So by and large, this is what we hope to achieve with this new API that we call the WebXR API. WebXR Device API is actually a collective of API, not a single API, that aims to support augmented reality. So a little bit of background. Before WebXR, there were already this WebVR API available. Not fully standardized, not fully, did not make it to a standard. But as the WebVR APIs grows, we came to realize, hey, we came to realize there's this technologies like augmented reality things that can also happens in the web itself, and they always share a lot of common attributes. For example, positioning thing in the spatial informations, and also the movement of objects, movement of users and whatnot. So the idea came about how we can actually merge this API and make it one single API to work with AR, VR, and MR itself. So that being said, coming from WebVR, it's now WebXR, and it supports augmented reality, where it used to don't. And then now it offers a clean and consistent and predictable sets of APIs that you can work with without having to think, hey, I'm going to work with VR, I have a different sets of code. I'm going to work with AR, I have a different sets of codes, and then there's a lot of things to do about. And as with any good API or good frameworks, any sort of consistent API is very, very helpful to the developers itself. You'll be able to guess how to use it right away without having to go through the documentation most of the time because of the consistency. And the advancement of the technology itself also allowed the WebXR to actually render 2x the pixels, double the pixels that is able to render in the web VR standards itself. Last but not least, it offers a unified input model, as I mentioned earlier, that with one single API, you can interact with all different kinds of controllers for your users interacting with your applications. Yep. This is just a quick one. We're not going to go through the codes and how it works, but by and large, the life cycle of a WebXR application goes by starting with curing the XR devices. Because when you are coming from a browser, you always know that most of the devices, not all devices support XR. For example, if you go with a very old smartphone, right, with your browser, you probably don't have the functionality, the capability by the device itself. So you have to do query on the features. The old way of us doing this has always been detecting platform. Now, if Chrome do this, if Safari do that and whatnot, right? But I suppose being a web developers, we know now that the best way to do this is really going with feature detections. So just check navigator.xr is available, then you can start to render the XR functionality. When you review XR functionality, meaning to say, it actually shows, hey, you know what, you can actually enter VR, you can enter AR, just by showing this button to the users itself. And if the users would like to, they can just click on the button to initiate. As any WebXR initiation has to be initiated by the user's actions, namely the user click itself. So you cannot just go into web application and then start to initiate an XR sessions. So once user initiate, then you request the XR sessions, and then you can run the render loop. Render loop are basically, just like any graphical elements, you basically have to render many frames per second of your objects in the virtual world itself. So the same goes from here. Now this is the entire life cycle of the XR web app, but these are very low level thing. As in most of the time, if you're going to build entire web applications, you are not likely to also just use JavaScript by itself. You would employ some form of library, some form of framework to do the same. So the same for WebXR. We don't expect you to dive deep into the low-level code and stuff. There are many form of frameworks that you can use to actually get into this. So I'm just going to use the rest of the sessions to share with you guys, like in 10 minutes, how we can build a very simple virtual an art gallery showing artworks from that you retrieve from NFT assets of a wallet itself. Okay. Oh, sorry, I forgot. Support, the most important questions. Almost all web browsers today has support for WebXR. iOS, I mean, the most asked question, iOS Safari. iOS Safari support WebXR from 15.4 onwards. Now it's 15.5, but it's behind experimental flag. So you have to enable the experimental flag for now. But Apple also keep full support for WebXR specs. So we expect more comprehensive support coming soon. Yep, demo time. So I'm just going to do two things. Number one, I'm just going to show you how this WebXR application likes. And then number two, I'm just going to build a very simple XR application with you guys. So as you can see, I can full screen this thing, right? So no distraction. So I'm actually at the WebXR sample site. You can see there's a couple of things you can do. I'm just going to show a few things. Number one is the VR sessions. You can see if I'm running on my phone, Samsung S21 without polyfill. If I actually just jump into a VR session, okay, I'm currently rendering the world planet. You can see here, running at 60 frames per second on the mobile devices with a virtual world. So if you're concerned about performance issue, it's really nothing too much you have to be worried about. And then let's jump into another example. Another one is the VR session, but because of time limitation, I'm just going to jump into AR plus the angle heat test. So as we mentioned just now, in a world of augmented reality, you can also do heat tests to measure the depth of a space itself, the spatial information, and you can render objects at different places. For example, let's try this. So you can see currently what I'm doing, I actually initiated augmented reality sessions, and what I need to do is to try to move around, because when I move around, what it does is that it's trying to calibrate and measure a little bit of the space. Then you can see there's an ankle that is actually being rendered. You can see the ankles roughly know the space, and if I like, I can just I'm just going to give Jaslyn a flower here. There you go. There's one flower in front of you. And on the head, okay, you're pushing the limit of the API, but I'm just going to put it on your table. Yeah, okay, you can see this one on the table. So as you can see, it does not only render information on your screen, because that's child's play, but it actually measures spatial information with your camera to actually try to determine the depth, the heights, and informations. So that with this kind of information, you can render a lot of things. For example, you can make sure a frog jumping on the table, not jumping out of the table and whatnot. So there is so much more you can do, right? And you can see the performance, it's really not so much of an issue. Of course, you don't have a lot of complex objects. It's basically all low poly model at this point in time. In terms of performance for AR, it's usually running about at 30-ish frame per second. Yeah, you can see this is the same thing that we render from VR just now. We are running at 26, 30-ish frame per second, and there should be a sun here somewhere. Sorry. Yeah. Okay. All right. Let's jump into some demo. Am I too short? Oh, this is too short. Okay. Right. So what we are going to do now is that I'm actually building on the view applications. You can just do any application that you want. What's the run right there? Okay. I love to do with Angular just for clarification's sake. Yeah, Angular is good. Okay. So as you can see, I actually bootstrap a simple web application, a view application with nothing but a WebXR demo. So as I mentioned just now, we can build this entire thing with low-level API, but this is not something that you wanted to do. So for rendering of 3D world, one of the most popular library will probably be Three.js. I'm sure a lot of you may have heard of it. But building on Three.js also takes some sort of skill, and it's not something that we can actually just finish doing the demo here. So what we're going to do is that we will be using this library called A-Frame. That A-Frame actually is using 3GS plus WebXR to help you to build a virtual world. So as with any virtual world, if you're working on Unity as well, the first thing that you always do is to define a world. In this case, we use a scene. Scene. All right. So as you can see in the scene, there's a couple of things that you can define in the scenes. For example, you want to define the assets that you'll be using, the background, and of course the event and whatnot. So if you look into the code, is this too small? My code, you can see, right? Let me just hide this. Just the color. I will unlock. I will highlight then. Okay, so the first thing that we'll need is basically to enable a scene tag. Sorry. There you are. Okay, so what I'm going to do is that I specify that I have a light blue background, and then let's remove the physics because we don't have enough time for the physics. But so if I have this thing now, if I go into the application, you see, I have a 3D world. Congratulations, you guys can leave now. Okay, now you have a scene, great. As with any application, when we learn new things, right, we do hello world, right? In the 3D world, hello world, we usually try to render a 3D object, a cylinder, a cone, and also a square. But let's just do a simpler one. I mean, I can just do this now. Oops. Yeah. So if I actually do this cylinder, I'm just going to say, hey, I'm going to render a cylinder at a position of 0, 10, 0. In the measurements, the unit of measurements in virtual world is actually in the form of meter. So this is like, I'm going to have an object rendered at the center, x, y, 0, and y at 10, meaning you say 10 meter high, and also the 0 meter depth itself. And then I don't have any rotations. We can do rotations later. Okay, so there you have it. Let me just refresh. So now you don't see the cylinder because I am at the same position as well. If I actually look up a little bit, sorry. I don't see it. There you are. Okay, this is on top. It's too tall for me. I'm just going to bring it down a little bit. So it's 1 meter tall. You can see it comes down here. So what we are going to do next is that cylinder by cylinder, we are going to build an art gallery together with all of you. Okay, we talk about cylinder because there's no sense of spatial because you don't have a place to stand on. So by default, generally you wanted to start with a plane first. But by starting a plane, you can do a plane. And then you always have to do the rotation of the plane to make it flat. And then you can make it the scale of 100 meter and 100 meter wide. There we have it. Because my plane, I did not render anything. I can it's just white color, so I can make the plane in any color that I like. Say for example, I'm going to do color yellow, and then I'll have a yellow plane, right? So we are very close to our art gallery now. So this is really not nice lah. So let's play with texture, right? So our art gallery should have what sort of texture? Glass, mosaic texture. We do what we do best, get from the internet. Okay, so I probably have a mosaic texture. Which of them I can steal? Let me see. No, because some of the source, right, like 1, 2, 3 RF, you know lah, you cannot use. Adobe Stock, you cannot use. Okay, actually, the objective of this exercise to tell you that there is a cross-origin issue, so you cannot directly refer from someone else. And for sake of simplicity, I actually have it prepared. I'm just going to enable in our asset tag here. Oops, sorry. So I actually have a ground called the floor museum texture. And inside, whatever that you put inside a asset, right, is basically like your asset library, asset manager itself. Whatever you put there will be preloaded and pre-cached for you, so you can use it later in the space. You don't want to be running around, then suddenly your floor is not loaded, then you have the floor, right? And so, of course, a lot of things you can load dynamically, but most of the time you don't do VR in that sense. You try to pre-cache information. So this is how you can pre-cache with an A asset. So at this point in time, I actually cache this floor museum, and I give it an ID called ground. So what I will do is that I just go to the plane itself and give it a SRC ground. There you go. Ta-dang! Oops, sorry. Ta-dang! Yay! We have a floor with a mosaic, right? Bear with me, it's not the best in the world, but we are getting closer. Okay, now what do we have? So we have a plane with a floor with the textures, but more importantly, in a virtual world, you wanted to be moving around, right? If you look at this thing, right, do you feel that I'm like very short? I mean, not that I'm short, but this camera is very short. So we would want to move the camera upwards a little bit. What you can do is actually specify a camera. So there's two ways you can specify a camera. Either you specify it as in form of a camera, or you use a entity. Entity is think of it like a div in our HTML, where it's nothing and then you can put things into it, right? It's a div itself. So you can put entity and then specify a camera attributes to it, and then you are basically making it a camera. So another thing about camera is that you don't want to just put a camera and let it move around, because you run the different kind of distortion, and especially you're moving people, just like your head. Your head is not moving, but your body is moving. So you can have this another object called a rig itself. So you attach your camera on top of it. So when your head is just doing the rotational functionality, and then your body is doing the transitional functionality. You can simply do that by actually specifying another object in between them. There you have it. And then also go into it is that you can see I actually have a camera position at 12 meter high. How high is 12 meter? Very tall. And then I also put a looks control attributes to it. So when I put looks control, it means you say it actually initiate the mouse movement control. So it's like Counter-Strike, you move around, you can shoot people. Yeah, that's looks control. And then you have also a WSD controls. Anyone don't know what's WSD control? Sorry? What is it? You're asking something, right? No? No? Okay. If you don't know what is WASD control, right, you can actually leave now. WSD control is basically your games control. When you play games, right, you move forward, backward, left, right. This is the standard WSD control. More advanced one, you have QE, where you tilt a little bit. So WSD control basically allows you to move around with the persons. And this same WSD control, apart from my keyboard itself, it also does the same thing for my controller if move up, left, right as well. So remember, just now we talk about unifying controller models. This is what they are trying to do. One set of API helps you to manage different kind of devices. Yeah, and then I'm trying to cheat a little bit, so I actually enable a special properties fly through. So I can actually fly in this space. Hey, there you are. You can see I can actually fly upwards, downwards with my controller. And mind me, if I am actually, how do I do this? Let me throw it's back. I'm just going to do a port forwarding and local. Sorry about the typo. Host. I keep looking at the time, so I'm getting more nervous. Okay, so as I mentioned just now, right, whatever we build, it actually supports any kind of devices that the API support itself. In this case, if you look at my devices, I'm rendering my localhost now. Okay, no weird messages. There we are. Yeah, there you are. So this is the same exact virtual world that we have built in our localhost now, and you have the same thing you can see here. And if you like, right, you can actually, because my device support AR, you can actually also jump into AR directly from the same thing that we have built. You have AR, and then you have a plane. Not the best way to demonstrate AR, but you get the idea. Where's the cylinder? Somewhere lah, you know, you get it lah. Okay, let me come back to this first. Okay, so very close to our art gallery now. So art gallery, you need to have a beautiful object, lights, canvas, the frame and whatnot, right? So there's a lot of things to do. So I have like, what, 20 minutes now? Okay, so what we're going to do is that, so one of the things that we do, we don't want to be building everything from scratch. Like when you build application, when you build a car, you don't want to be building your own tire, right? The same thing for the virtual world. A lot of time you don't have to build the entire thing yourself. So what you can do is that you can use 3D models that was built by other people. The easiest way for you to do this is go to Google, the best website in the world, and type free 3D models. I can guarantee you can find anything you want. See? 3D models for free. And you can have any of these things into your virtual world, your metaverse, for mostly free. But because I'm not a cheapo, so I actually paid for a model, very expensive. I paid $3 for it, and I'm going to show you. Okay, 1, 2, ta-da! Yeah, ta-da! Yeah, I have a art gallery now. But you can see the floor is flickering, right? Because I don't need that plane. The 3D models actually handle the plane for me already. So I'm just going to hide it. But if you want to override the plane, you can just put it like 0.1 meter higher. But I mean, there's more way you can, there are more comprehensive way you can do. That's not the best way. Yes, congratulations. We have built our first art gallery with a cylinder there. That's not the end of it. Okay, the thing is, you see, it's very dark, right? In normal settings, when you go to an art gallery, you can see it's very bright. So, okay, so what we need to do, we need to let there be lights. So, so I'm going to render a light here somewhere. Okay, so we can render a light with A lights, LIGHD, and then I can give it like intensity. For the sake of demo, I'm just going to give it a very strong intensity 10, and then positions. I'm going to give it 0, 10, 0. Like, okay, 10 is too high, maybe like 5. Okay, so you jump into it, right? You can see, ta-da! I have a light shining out of nowhere as from center, and because it's so intense, the entire floor becomes so white, right? So not the best idea. Let me just go back to it and make it 1. See, but the problem is, even I have it at 1, sorry, no, it's not supposed to be like this, but even I have it at 1, right? The problem is that as we work with any sort of virtual world, even in Unity, the same thing is when you actually put in the light, right? The default global light setting will be replaced. So you should probably want to work on your own ambient lights and different kind of global light source and whatnot. But because today is not a 3D sessions, so we'll skip all that. I'll just tell you how I do it with a. I basically put a. Where is my, there you are. So I basically just put a box. I'm lazy to draw a light, so I put a box. Scale of 1 meter wide, 1 meter tall, and 1 meter deep. Color of white, give the position at the center, and I give a light source of ambient light source, white color, intensity 2. And then I will have something like this. Yeah. Okay. And you want to see the light source? Not, it's hanging up there. There you are, the white cube, you see? That's light source. But of course, this is not the best way to do it, just for demonstration purpose. I don't want to go around seeing all the web VR game all like this one. Don't. Okay. So okay, now we have the art gallery. Remember, we talked about NFT. We are not going to spend too much time talking about NFT, but what we will be doing now is really trying to interact with a wallet, with my wallet, my demo wallet, to read the NFT assets in the wallet and use the assets to display in the art frames itself. Okay, so how we can do that? There's many ways you can interact with your wallet. The most commonly used are things like Web3.js, or Ether.js. Depending on the camp you are, you can use different kind of JS. You can different kind of library. But for simplicity's sake, I'm just going to use a third-party service, a paid service called Moralis. Yeah, very hard to pronounce. Moralis. That it works a little bit like a, I cannot say this, a little bit like a Firebase for Web3. But Firebase is better. Firebase haven't implemented the wallet support, the Web3 support just yet. So if not, Firebase will be better. Okay. Again, I will just skip through all of the setup and whatnot. I'm just going to show you what I have here is a Moralis service. Basically, what we do is that we initialize the application in our applications. Initialize the library in our application with our server URL, your ID, and whatnot that you can get from signing up from the applications. We are just going to do 2 things. Number 1, we're going to log in by login meaning you say you get your users to sign the wallet to give you the permission to read the content in your wallet itself. So that's login. And this functionality is entirely provided by Moralis. But if you use Web3.js or Ether.js, you can do equally the same. It's just that this one makes things simpler for me. And the signing message basically meaning to say, hey, how do you want to sign up? When people sign up, you want to tell them, hey, you're signing this up, you don't have to pay for anything, there's no network fee, no gas fee, no nothing. You want to let them be assured. These are the things that you say. And then the chain ID is basically the network that you wanted to work with yourself. Today we are working with a Polygon network, the testnet that is called Mumbai testnet. So the chain ID is 80,001. Try catch error and resolve promises. That's something that's simple. I'm just going to show you the Moralis documentation quickly to show you the functions. Okay, 15 minutes left. Very simple. Just go to Web3 API. You can see. Okay, so go to users. You can see Web3 authentications. You can have all the information in the documentation and help yourself. It supports MetaMask, Wallet Connect, and a bunch of stuff. All you have to call is this function, and as I show you just now. And then after you call the functions, you want to read the NFT, the available. So basically, you call these functions called Moralis Web3 API and accounts to get the NFTs available. So once you get the NFT, you get an array of the NFT, and then you do whatever passing you wanted to do. Because by nature, right, NFT is basically just a token in the blockchain database that has a token URL refer to external source for information. The external source can be a centralized server, can be a decentralized server like the IPFS or RV networks. But that's just about it. Okay, but because of different people, they would implement differently. You probably wanted to pass your NFT metadata to use it and in your application. Another thing you probably want to do also, because many of the images in your NFT are probably in form of IPFS, meaning you say it's decentralized, a little bit like BitTorrent lah. You know, when you download things from torrent, right? All these files are actually separated into many different places. So you try to pull everything in. You don't have the guaranteed success on the same timeline. So what you can do is that on the server you can cache the image itself and display it to user when you have a matching tokens. But that's roughly about it. That's what we do. We replace IPFS and blah blah blah. And then just go back to the HTML. I am just going to show the login button here. The login button is when I click login, it actually just trigger the login function we showed just now, and then your wallet address. And then retrieve your stuff. Okay, element is missing. Which element is missing? Here you are. Okay, so now you can see our art gallery. We have a login button now. Yeah, once I log in, it will try to ask me to electric power. Sorry, I just realized I ran out of battery. Which is the this one. 还有 OK 那边有 port 但是不够长有 power delivery 这里所以可以放这个啦 charge now. Okay, good. So once I click on the login functions, it will ask me to authenticate with my MetaMask, and then I'll unlock my MetaMask. Okay, I'm at the right account, the demo account, and then see what the time I say sign in to log in to these applications and whatnot. Then I just click sign in. Then you can see I have access to the wallet itself, and behind the scenes, I'm actually reading the NFT assets as mentioned just now with the functions called the get NFT functions provided by Moralis, and it does its own passing. So you can see these are the 4 images that I get from my wallet itself. Okay, and if you look at this, right, what I did is really I put up a 4 image canvas and position them nicely in the 4 art gallery, and then conditionally turn it on off depending on the NFT I fetch lah. So nothing fancy there. You can see, so I may need to reload a bit. Okay, let me just log in again. So as you can see, I've logged in already. Remember just now we used the WebXR API. It allows you to trigger VR if you want to and whatnot. So you can see because my laptop supports VR functionality and the button is here, you can click into it. Ta-da, I'm in full VR. Okay, but if I'm in full VR, I don't get my interface anymore. That's the problem. You still can build your interface in VR. I'm just lazy, so I build it on the web layer. Okay, now I have these four images that I have, right? I'm just going to click on one to select it. And I have my images displayed on the canvas, and let's just have all of them together. Yep. So that's it. We have our art gallery with the access from NFT. I know it's super express, but what I'm trying to do here today is really to deliver the concept that the concept is really, really simple, and every one of us here can do the same thing as well. Lastly, there's a disclaimer that I like to make. Quick disclaimer. Not disclaimer, for rather credit. You can see these three very nice artworks. I want to show you something. Okay, let me help you. How do? Oh, okay. Here, you can see, right? The name is blurred. These artworks, all these three artworks is actually drawn by our GDG Georgetown community manager, Luis. Where's Luis? Yeah. He's also she's also a digital illustrator herself, and she contributed these three artworks to the project. If you want to buy this NFT, you can talk to me. Okay, I think that's all I wanted to be able to show today. I hope we can show more because there's so much fun doing this, but I don't have enough time. But for a learning purpose, these are the informations. You can get all the information I shared just now, and spend some time exploring it. I hope you enjoy it, and let's build the better web together. Thank you very much. I got 3 stuff to give away some more. Any questions? Okay, the lady, very fast. Sure.
For the code.8 if you set fly to false vibrate.
A fly to false means it will actually stick to the ground. You still can move around, but you cannot move outside from the ground. So it's like flying lah. Yeah, then you will be just moving on the y-axis itself. Yeah, you cannot translate or top down in that sense. Yeah, but if you enable fly, then you have full flexibility lah. Yeah, no problem. There's one for you. Don't mind if I throw it to you? Okay, let it go. Oh, sorry. Right, anyone else? Quick one. I'll pick someone from the side. Yeah. Okay. Yes, Nathan.
I noticed that you're using Molaris,
Yep.
right? So you're using Molaris. So what are the advantage of using Molaris compared to the open source library?
Advantage. So yeah. A good question actually. Molaris actually provides pretty much comprehensive sets of services like image hosting database, other APIs, transaction APIs with the RPC API with the blockchain database, and a lot more stuff itself. Whereas, meaning to say, if you're going to build an application entirely on Molaris with your own front end, then you can do that. You don't even need to have your own backend. Yeah, you can have your own user database, authentications, everything with Molaris itself. Where the open source one, right, for example, Web3.js, Ether.js, it's basically just a library for you to interact, but doesn't have a backend for you. You have to build your own backend. Firebase is better. we cannot say basically it's Firebase because Firebase is better. Great, thank you. Anyone else? Sorry, sir.
Okay, thanks for the explanation. Based on your observation, the Immersive WebXR library, does it support the collision detection like Unity? And then does it provide you the interaction with the world itself? Like for example, in the VR, like we have a kind of we can interact with the external. Let's say I want to click the image, and then we automatically does the library provide.
Right. So object interactions.
Yes.
To put it this way, WebXR API does not do 3D renderations, does not do 3D interactions, but rather it's a low-level APIs that helps to connect with devices and provide a set of consistent API to whoever that needs it. And in this case, what you mentioned just now are basically like 3JS or A-Frame actually uses this API to provide the interactions for you. But by and large, the object interaction still happens with on the application layer. The only when it's needed, for example, the input and output layer is handled with WebXR itself. For example, showing the screen, for example, reading input from controllers, these are handled by WebXR. So WebXR is really a device API that helps you to connect your 3D applications with the devices. Yeah. Thank you. Like, can throw it to you? There you go. Last one. Hi. Short answer is yes, you can. Yeah. I mean, you mean now? Oh, I mean, I don't have a demo. Whatever you built just now, right? To do a virtual auction, you pretty much need your own backend. You probably need just add in a little bit of WebSocket and some business logic. You can do that. You can. The short answer is that you can build all of this thing in the entire VR world. Yeah. I wanted to point out very important misconception about VR is that people think about VR as in like you need to have a VR headset, but you don't have to, because VR can be accessed with a VR headset, can be accessed with a very low entry VR headsets, or can even be accessed with my phone, as you can see just now. I turned off already, but I can access with my phone or even my computer. So you don't have to have it doesn't have to have like full VR headset to be immersed in VR itself. Yeah, great. But I'm just going to give you a first time now. Do I still take questions, or I can just pass it back to you? Okay. Don't mind, throw it to you. Thank you. Oh, sorry. I'm totally sorry. I wasn't aware you're holding a cup. Sorry. Okay.
One last question, I guess.
Yep. Two. Any more? No more gift though. Yes.
Okay, in your opinion, right, where is the Google position in this Metaverse things?
Okay. First of all, I'm in no position to represent Google in any sense. I mean, my opinion is not important in this sense, but also I think it's important to answer your questions. For me, the Metaverse or blockchain technology or NFT technologies at the end of the day is just another set of technology. Of course, there were a lot of hypes previously, but there is, to me, I decoupled both of them. It doesn't have to tie together. For me, for example, I built this Arteesan art framework, right? I actually uses NFT for provenance, for certificates of authentications, because one of the things we try to solve here is that if you buy an artwork, right, they give you a certificate of authenticity. It comes in form of paper. So the problem inherited with paper is that number one, is easily damageable. It can be fraud and it can be lost. Right. By nature of NFT, it has a few attributes that we think it's helpful to the situation. Number one, the content is immutable, meaning you say no one can fraud the content. Number two, is indestructible unless you take down the entire networks. Of course, some network does go down sometimes. But also more importantly, because it's publicly verifiable. If you own an artworks, right, you want to be able to show that I have this genuine artwork and is publicly verifiable. So we uses that technology to try to solve some real world pinpoint that we identify, right? But as of Google stance, I think Google is not too against, because I remember Google Cloud was hosting a related events online before. Yeah, hope that somewhat answer your questions. Thank you. That's another one, right, just now.
Hello.
Hi.
I'm Joe.
Hi, Joe.
Basically, I also want to know about the AR. Is there any application AR for handicap, like blind people, like they want to open, when they want to cross the road, right? Whether AR can help them to solve their daily issue?
Sorry, I think I missed your question. Can you try again?
This AR, right?
Uh-huh.
I think that you can detect the space, detect the image. So for blind people, right, they cannot see things like so whether AR can help them.
They cannot see.
The rules.
Okay, you mean how we can use AR to help them, right? It's a hard question. On top of my mind, I don't have an answer actually, to be honest with you. But because AR by and large is a very visual heavy set of technology. So if you're referring to someone that had eyesight challenge, then I probably think this may not be the best solutions to try to solve the problem.
Yeah. The AI and MR is different, right? MR is look like more advanced.
Yeah.
So do you need to have an AI inside also, so that you can watch it together?
Do we need what? You mean AI?
Yeah.
Oh, so I would think it will be a bundling of various technologies to make more advanced techniques happen. For example, just now the renderization I showed the flowers one, right? Yeah, it detects spaces, it detects high like spatial informations, but it's still very flawed one. For example, if I put another one beside, right, then the two models also overlapping, and that needs more advanced handling. This is more of a proof of concept. But if you have AI to empower with this information as input, I'm very sure it will come out as a much more complete solutions. Yeah, I hope that's an answer to you. Okay, that's one.
For the flower, how's your phone detected that? Is it the
Yeah, it's basically just we call this thing called a ray casting. Basically what it does is that it does measurements with your camera input. So from shadow, from heights and stuff of objects. So remember just now, before I start, I need to do a little bit of calibrations. I need to move the camera around and whatnot. So what it does is that it's try to look for objects in the world, in the real world, and try to assume some mathematical positioning or stuff. From there, you can sort of extrapolate the spatial information in the scene. Yeah, thank you. So there you have it. Thank you, everyone. Have a good day.